In this video, we are going to look at how to compare two proportions. So in other words, we want to compare two success rates. Say for example, suppose you have two methods to detect cancer, and you want to compare which one is better. And if you can detect the cancer correct, the one with the higher rate of detection rate is a better one. Okay, so that's what, in other words, we are into this binomial setup, proportions. So we basically so this is the population 1 or the proportion. So it's like a binomial setup. So each trial, success or failure, and the probability of success is P1, and the failure is 1 minus P1, which is Q1. And for the second one, the success rate is P2, and the failure rate is 1 minus P2, which is Q2. So you have already seen so how to deal with one proportions. So how to construct confidence intervals for so say P1, or the other way, how to do testing of hypothesis on P. Okay, so for one proportions. So here we want to compare two proportions, or the other way around, we want to construct confidence intervals for the difference between those two proportions, P1 minus P2. So we are going to use the same approach. So it's basically you pull a random sample from the proportion 1, so the number of in-1 trials, so which is the sample proportion. I'm going to use P1 hat, the proportion of from the first sample, proportion P1 hat, which is the number of successes divided by N1, which is the sample size, first sample size, the second sample N2, and the proportion rate, sample proportion P2 hat, is going to be the number of successes in the second sample divided by N2. So you already know that for large N1 from the central limit theorem, so this is approximately normally distributed and with P1, and the variance is going to be P1 Q1 over N1. So in the past we had only one, just P, Q and N. Okay, so now since we have two samples, I'm going to use the subscript P1 over there, means that is coming for the population 1 or the sample 1. Okay, so here for the sample 2, P2 hat for large N, N2 has a, this is going to follow approximately normally distributed with P2, and the variance is P2 Q2 over N2. So the larger than, same thing as before, larger than better the approximation. Okay, so at the end we need large N. So you have seen that this going from here to here in the past for the difference between two means, so the same story. Okay, so here you have two normal distributions. For this difference, P1 hat minus P2 hat, that will follow another normal distribution, because this is normal, this is normal. The difference will follow another normal distribution. The mean is going to be the difference between this minus that, but the variance is going to be the plus, this variance plus this variance. Okay, the same situation. As long as these two samples are independent, this step is correct. So if this is correct, so if you get rid of the mean and then divided by the square root of that, that is going to follow the normal distribution. So let us look at do the hypothesis testing. Okay, so we want to compare this. In other words, we want to see whether P1 equal to P2. In different words, P1 minus P2 equal to 0. So the alternative hypothesis, we want to test one of those three alternative hypotheses. This is very similar to what we did with the means. So P1 minus P2 is greater than 0, and P1, the first type of alternative hypothesis, So in other words, so this rate is bigger than this rate. So the part 2, the B, P1 minus P2 less than 0, so not equal to. So here we are saying that the part C, whether they are equal 0 or not equal to 0, okay, two-tailed test. So now what we do is that, so under the null hypothesis, in other words, when this part going from here to here is same as before, okay. So under the null hypothesis means assuming this is correct, so what we are going to do is that we are going to get a common estimate for this p-value. So when under that means that this is same as that, so p-value is going to be the same. So we are going to estimate that p-value, which we are going to say that the p tilde by combining both samples together. Okay, so in other words, p tilde is the number of S's in both samples, in this sample as well as in this sample. Okay, both samples, number of S's in both samples divided by the total number of sample size, n1 plus n2. So the q tilde is 1 minus p tilde. Or the other way around, instead of saying that, this q tilde is the number of failures in both samples divided by n1 plus n2, which is the same thing. So once you get that, so what we're going to do is that, so we are going to calculate this is supposed to follow the z curve. So we are going to calculate it. We are going to replace these parameters, these things, by these values. So under this hypothesis, this part is same as that. In other words, this P1 and P2, they are the same. So we are going to replace this P1 and P2 both by P tilde, Q1 and Q2 both by Q tilde. So in other words, this is going to be P tilde, this is Q tilde divided by N1, and this part is going to be P tilde, Q tilde divided by N2. So then we, using the samples values, we can calculate that. We know that this is supposed to follow a normal distribution. So that's why we say that is a sample Z. So you calculate the sample Z and compare against the Z table value. Okay. So the Z table value depend on whether this hypothesis or that. So if this is correct, your rejection region the same as before, okay, with the mean. So the rejection region is going to be in the upper tail. So if this is correct, basically the rejection region, what you need is that on this side, okay, so here is alpha, so here is Z alpha, so this is the rejection region. So if this value is in here, then you reject the null hypothesis and accept the alternative hypothesis. Otherwise you cannot reject H naught. Okay, so the same setup. So if you are dealing with this, rejection region is going to be in the lower tail on this side, alpha is here, and so for this one there would be two rejection regions, so you got to split your alpha into two. So this is going to be Z alpha over 2, this is going to be minus Z alpha over 2. So either in here or in here, you reject the null hypothesis and accept the alternative. Okay, so use the Z table, finding p values. The observed significance level is exactly the same, but you use the Z table values, okay, to figure out that. So with the example, I will show you that. So the assumptions now, so the assumptions is going to be here, the number of S's and number of F's, successes and failures for both samples must be 5 or more for both samples. So see, you remember that. So with one sample case, we said that it's a 10 or more. Well, so in this case, so basically we kind of, you have two samples, essentially kind of, like we estimate these things combining two samples, kind of that's where that is 5 is coming from, okay? But some books is still use that is 10 anyway. So this is probably better anyway, but you can use either 5 or more. So either, at least this must be correct, okay? Otherwise this method is not good. So 5 or more, so you use basically this method. N should be large enough at least with this condition. And the second condition, those two samples must be random samples. Okay, that part is necessary as well in two places actually. One is that, and the other one is going from this place to that place. Okay, but anyway, these are the assumptions. Okay, so that is the hypothesis testing part. So for the confidence interval is almost the same way. So there are two commonly used methods in general. So one method basically is very similar to, so sometimes it's known as a large sample method, but in this case that samples must be large, okay? So in other words, number of successes and number of failures in both samples must be the minimum 10. Most books says that minimum 15, but must be minimum 10, okay? So must be that. So if that's the case, you remember that in this, so we did the same thing with one sample case. One sample case, basically we had, so here this way and without that, one sample case, okay? So this P hat, Q hat and that, so we did not have this as well as that. So that was that. So here you have two samples. So that's P1 hat minus P2 hat, the Z table value. So you might want to even look at this actually, compare with this. So it's very much, not that actually, you need to look at right here actually. So this thing, the Z table value times this part, okay? This part, Z table value, and that one estimated value for that. So you are replacing these things by the tilde part, okay? So this one. So actually it's not the tilde for that, okay? So it's the P hat. So it's not that actually, okay? So because this is coming under this hypothesis, that is not the case, okay? So you are replacing this thing by P hat, Q hat, P2 hat, Q2 hat. So that is that one. So the second method, is going to go like that. We did it for before that. If you look at your note, the previous estimate I mentioned. The second method, this is one sample case, okay? Second method, we use this tilde thing, but that the number of successes plus 2 and the sample size plus 4. And then replace everything like that with the P's and Q's, okay? So here you have two samples, so instead of using plus 2 and plus 4, so you use a plus 1 and plus 2 right there for each sample, okay? So in other words, what is going on now, so here, so P1 tilde, so use number of successes for the first sample, plus 1, the number of sample size plus 2, and the Q2 hat is going to be 1 minus P tilde 1, or the other way, this part is the number of failures in the first sample plus 1 divided by N1 plus 2. Alright, for the second sample, again you do the same thing, P2 tilde now, and Q2 tilde, you calculate it. Once you get these 4, okay, so you replace, so it's very much here, P1 tilde hat, P2 tilde hat, and the Z table value. So here P1 tilde, Q1 tilde hat, okay, and then P2 tilde hat, Q2 tilde hat. So it's the same formula, okay, instead of having this hat and these things. so you use the tilde. So so that's what. Okay, so here the sample n1 must be at least 5 and n2 must be at least 5. So in other words, if you have a small sample, you want to use that. Okay, so I'll stop here, and in the next video I'll show you.